Watch a film of two billiard balls colliding. Run the footage backward, and the scene feels perfectly plausible. The equations guiding that impact. Schrödinger's wave law. Maxwell's light waves. Newton's gravity are time-symmetric. They do not prefer yesterday or tomorrow. Yet outside the chalked felt, glasses shatter, but never reassemble. Smoke escapes, but never retreats, and human memories grow in one direction only. Where does irreversibility arise if the bedrock is reversible? The answer hides in an ocean of overlooked degrees of freedom. Trillions of air molecules, stray photons, lattice vibrations. Every macroscopic event leaks quantum information into this environment. Phase relationships, those delicate alignments that let superpositions interfere, spread outward at nearly the speed of light, too fine-grained ever to be coaxed back. What looks like collapse is entanglement gone cosmically diffuse. Thus, the arrow of time is not carved by fundamental laws, but by practical impossibility. We cannot gather and reverse the countless whispers our actions shout into the world. Decoherence turns microscopic reversibility into everyday one-way traffic. Eggs that fall but do not uncrack. Stars that radiate but never reignite their spent photons. Imagine a coin balanced on its edge inside a perfect vacuum. Is it heads, tails, or both? In isolation, quantum rules would allow a superposed answer, but our universe refuses isolation. A single microwave photon brushing past can learn the coin's tilt. An infrared vibration in the table records a soft echo. Each interaction copies a fragment of which side into countless environmental bits. This copying is decoherence in action. System-environment entanglement that smears phase relations beyond retrieval. In a laboratory, physicists can watch it happen. Send C60 molecules through twin slits and gradually raise the ambient gas pressure. At a few collisions per millisecond, interference stripes fade like morning mist. The molecules are still in superposition. The scattered gas now carries the path information, rendering fringes invisible. The environment is an omnipresent camera with no off switch, sculpting reality by relentless surveillance. Classical states like definite positions and robust magnetic domains survive because they broadcast distinct, redundant signals that many observers can sample without disturbing the source. Quantum drafts that lack this redundancy dissolve almost instantly. In other words, the world we perceive is the subset of quantum possibilities that can keep a secret from nothing and no one. Not every quantum draft is doomed. Certain configurations, an atom's location, a dust mote's trajectory, a planet's orbit proved remarkably stout. Wojciech Zurek christened them pointer states, patterns that survive environmental scrutiny because they imprint clear, consistent records while shedding minimal phase ambiguity. The environment, acting like a cosmic publisher, copies those records into trillions of photons, phonons, and air molecules. This redundancy gives rise to quantum Darwinism. Just as biological traits spread by replication, it's only quantum states that can broadcast many identical templates become objectively real. Multiple observers sampling different pieces of the environment, reflected light here, scattered sound there, will all agree on the pointer state without ever disturbing it. Our shared classical world is thus the fittest survivor of an endless competition for informational airtime. Laboratories now film this survival contest. In Vienna, fullerene molecules traverse a 100 nanometer grating. Lower the background pressure and interference fringes gleam. Bleed a puff of argon gas and collisions erase stripes molecule by molecule. At MIT, superconducting qubits lose coherence in microseconds as stray infrared photons slip through shielding. Measurable on oscilloscope traces that sag from coherent oscillation to noisy plateau. From femtosecond electron diffraction to second-long ion-trapped clock qubits. Every platform maps a decay curve. Gaussian at first, exponential later, charting how swiftly the environment steals phase information. Collapse is not an event, but a diffusion, a bloom of entanglement radiating outward faster than we could hope to reverse. Because entanglement spreads one way, entropy must rise. Each micromeasurement adds bits of information the universe must keep track of, enlarging the environmental Hilbert space. Reversing that growth would demand recollecting every photon your breakfast cereal emitted into the kitchen walls. Possible in principle. absurd in practice. Thus, Loschmidt's paradox evaporates. Microscopic reversibility coexists with macroscopic irreversibility because the bookkeeping burden is grotesquely large. This link ties quantum mechanics to thermodynamics. Heat death, aging stars, melting ice, all trace back to the one-way leak of phase information into degrees of freedom we cannot corral. Time's arrow is not painted on the laws, but on our inability to gather scattered quantum breadcrumbs. If decoherence is entropy's advance guard, quantum error correction is the counteroffensive. The Shor code, surface codes, and cat codes distribute a logical qubit across dozens, or soon thousands of physical qubits. Local noise may flip or deafus some members, but parity checks catch and repair errors before they metastasize. In 2023, Google's Sycamore 2 maintained a logical qubit for an unprecedented millisecond, still brief, yet 50 times longer than its naked counterparts. Bosonic cat codes in 3D microwave cavities have lived hundreds of milliseconds. They're alive, plus dead photon cats, periodically refreshed by autonomous feedback. Each milestone nudges quantum processors toward the fault tolerance threshold, the point where error correction wins the war of attrition against the environment. Paradoxically, watching a system relentlessly can also freeze it, a phenomenon dubbed the quantum Zeno effect. Bombard a radioactive nucleus with rapid-fire measurements and its decay slows, held in limbo by the very gaze that would reveal its fate. More practical is dynamical decoupling, timed pulses that flip a qubits. Phase-making environmental noise cancel like alternating Tugavour poles. In nitrogen vacancy diamond sensors, Carpacil Myboom gill sequences stretch coherence from microseconds to seconds, letting the same crystal probe neural currents or map nanoscale magnetic textures. Nature, too, negotiates with decoherence. Photosynthetic complexes coupled just strongly enough to sample multiple energy pathways, yet swiftly hand off excitons before thermal vibrations dissolve coherence. Migratory birds protect spin-correlated radical pairs inside protein cages, extending entanglement to the microsecond window needed for magnetic sensing. On the engineering front, silicon foundries now grow crystals 99.999% free of spin-carrying silicon-29 isotopes, quelling hyperfine noise for electron spin qubits. Superconducting circuits incorporate purified tantalum to curb two-level defects, while levitated sphere interferometers chill nanoparticles with laser feedback, so environmental kicks arrive only every few seconds. Long enough, perhaps, to glimpse macroscopic superposition. Add these threads together, and the message sharpens. Classicality is a crowdsourced illusion. When countless fragments of the environment store identical copies of a pointer state, observers, humans, cameras, dust grains, sample overlapping subsets, and agree on facts, what they can never access is the lost phase information that once linked alternatives, now dispersed beyond recall. The sun appears simultaneously round to billions of eyes, because photons streaming from its surface encode that shape redundantly across the solar system. Quantum drafts of non-round suns certainly existed, but decoherence ranked them unfit. They could not broadcast a stable headline. Our deterministic common sense is, therefore, a weighted average of quantum possibilities, filtered by survival in the open informational marketplace. With this, our exploration of quantum foundations reaches its final curtain. We have met uncertainty, superposition, entanglement, and the environmental tide that hides their spectacle. All that remains is to reflect on what these layers reveal about meaning, memory, and wonder in outro, painted in probabilities but read as lived experience. Stand beneath the night sky and breathe in the quiet. To human senses, the universe feels immovable, stars fixed in their constellations, mountains anchored to the crust, history scrolling one frame at a time. Yet every photon in that starlight, every atom in those rocks, every heartbeat in your chest is balanced upon a scaffold of quantum possibilities. Drafts the cosmos keeps revising faster than any mortal eye can see. We began our journey with a single question posed by a beam of electrons. Could reality travel to paths at once? The double slit answered in ripples, yes and yes again. From there we followed uncertainty's restless hum. The rule that refuses pinpoint perfection so atoms may endure and galaxies may form. We watched superposition expand the universe's imagination, letting energy explore multiple futures before settling on one. We threaded entanglement between particles light years apart, and learned why those hidden webs rarely glitter in daylight. Decoherence. The world's relentless gossip, scattering information until classical certainty emerges as communal rumor. Together, these principles reveal a universe that is not optional. Not a polite veneer atop clockwork gears, but the gears themselves chromed in probability. Lubricated by phase, turning in silence until observation gives them voice. The chair beneath you, the bloodstream within you, the flame billions of kilometers away in the sun's core. Each is a story that might have unfolded otherwise, had quantum dice rolled a different way. And still, wonder grows. Engineers coax qubits to balance on quantum tightropes, building computers that will map proteins in hours, forecast climate in clarity, perhaps even crack the secrets of high-temperature superconductors. Astronomers listen for gravitational murmurs etched in space-time by primordial quantum foam. Biologists discover that the robin's midnight compass and the leaf's morning harvest both lean on fleeting entanglement to survive. In every discipline, what once felt like paradox now reads as opportunity. To call the quantum world weird is to admit we have measured it with rulers forged from everyday instinct. Replace those rulers with curiosity, and weirdness reframes as depth, an ocean whose swells and undercurrents sculpt every shoreline of existence. Dive deep enough, and you will not find chaos. You'll find coherence wearing masks. Probabilities weaving patterns so vast that life itself can walk upon them without ever noticing the threads. So the next time you look up, remember, the starlight striking your retina left its home millions of years ago as a superposed whisper, tunneled through interstellar dust by uncertainty, arrived as a photon whose twin may be entangled with a grain of cosmic dust you will never meet. In that single moment, history, chance, and observation converge, and reality, ever accommodating, chooses one of its many drafts to lay at your feet. This is Cosmic Canvas, where the universe is not only studied, but painted in meaning. Until next time, keep asking, keep looking up, never stop wondering.